What is up, everyone? How is it going? It has been quite a while since I have uploaded anything or done a live stream, and frankly, it's because, wow, it has been busy. I don't know about anybody else, but it seems like industry and just everything has been picking up, especially with all the shortages and everything. Just, my goodness, it has been crazy. So, with that said, I am actually streaming or actually recording this from a coffee shop in Tuscaloosa, my favorite coffee shop in Tuscaloosa, Alabama, Monarch Coffee. Shout out to them. But because of that, you might hear some stuff in the background, and there's not going to be any video or anything on this. But uh, so that said, a lot has been going on, and I wanted to take just a little while today to do a little bit of a recording on something that has been requested a lot. Um, and as you may know, my name's Jason Watts. I'm the Drives and Motion Specialist for Wesco and out of the Birmingham, Alabama office. Um, but I deal a lot with Siemens drives technology, and I'm the kind of that has been my focus for quite some time. And one of these drive technologies is the Siemens S120 drives, and hopefully you're familiar with those. But because today I'm going to be using a software package called SIZER to size up a fairly simple system. This software package is the package that I use to specify systems, especially S120 systems. Um, S120s have a lot of components and they're highly configurable and they have a lot of different applications they can do. So there's a lot of kind of little errors that you can make that can cause you a lot of headache. Well, using Sizer kind of eliminates all of that. So what I'm going to do is I'm going to go ahead and get Sizer pulled up here. And if you've never if you've never used this software, it, it it's very expansive, but there's kind of a lot of clicking that's involved, a lot of different dialog boxes and everything. But it it kind of steps you through everything. I'm gonna go through and just kind of make up an imaginary system today with a couple of motors and show you some of the basics. The first time you open up Sizer, you probably will have something like this. There'll be a little dialogue that says everything's up to you. Like they don't accept responsibility for the sizing, but this tool really does give you the best option of not messing something up. So if you've never used Sizer before, the first thing I would normally do is go up to Tools and Options, and there's a couple of things in here that you'd want to set. The first is this dimensioning settings. No, sorry, country settings. Make sure the unit system, if you're going to be doing horsepower, make sure this is in NEMA because otherwise you're going to be having to go through and change everything on the fly as you're punching it in to from kilowatts to horsepower. Also, make sure that you do North American components if you're in North America. If you're not, then you can select IEC. And if in the US we have distribution, and so if you call up your distributor and give them a part number for a component that that is out of Europe, we may not actually be able to find or sell that component. So this selection here hopefully keeps that from happening. So the last thing I would check is a supply system pre-assignment. If you're on a 480 volt system, go ahead and select this because all the calculations are based off of this. Yes, you could change that later, but it's nice if you're going to be doing these just to go ahead and set it if you're in the US. If you're not, you can obviously change it to your supply system. So we're going to go in here. We're just going to make a new project. So over here on the left-hand side, if you already have a project, the last couple of projects opened will be over here on the right-hand side. But we're going to make a new one. We're just going to name it Demo Project. Okay. And we are going to make sure our project path here is a place that we know that we can get to. So that's what that is. Click Create Project. So I've told you a little bit about what SIZER can do, we are not going to go through anywhere near the capabilities of SIZER. We're going to do the very basics just so you can kind of go through and do an S120 system and not quite have as much worry about specifying it. Now, if you are doing an S120 system, it's always a good thing to reach out to your local application engineer just to kind of look over your shoulder, just to make sure you have the right cables for the right applications, things like that. SIZER will give you good part numbers, but sometimes they're not the right part numbers based on the application, and we'll might touch on that a little bit. First thing you want to do is go into New Drive System. We're going to start this up. For this project, we're going to be doing a multi-axis converter, and for just terminology, for single drives, this would be AC to AC. So G120s, Micromasters, things like that. Multi-axis is going to be a common DC bus lineup. So you're going to have a rectifier and then inverters hanging off that common DC bus. So first thing you got to do in an S120 system is a multi-axis system is to select what type of rectifier you want. Let's just select basic module now. And then as you notice, things just kind of click along through. We're just going to say we can name this our drive motor. We can call that. If you notice here, there's a lot of different Siemens options. So if you're using a Siemens motor, most of it's already pulled it in and loaded into the system, so which is nice. But what we're going to do is just use like say we're using a Black Max, like a Baldor Black Max motor. So an induction motor, TEFC. So we're just going to say third-party motor. And over here on this right side here, select vector control, because we're going to be doing sensorless vector control on this motor. Again, like I said before, a lot of these things don't really matter, but it's nice to just put them in because that does affect the performance expectations. For this, it won't matter though. So let's click motor data specification. 9 times out of 10, that's how you're going to do it. You're just going to say, I have a 10 horsepower motor and this much current, and we're going to go from there. So this little screen here is called your project workflow, and it kind of contains everything that you need to do in order to specify these systems. Now, as you go through, you're going to see these little green check marks. The more green check marks, the better, obviously. So, and once you get to the very end, everything will be green and you can kind of print out the system. First thing that we always do is we specify the motor. And if this were kind of a newly designed system, there's some other tools to be able to calculate how much torque is actually needed. But we're not going to do that. We're just going to say 10 horsepower motors. So we click on our first little dialog box there to specify the motor. This little checkbox here, when we have our final parts list, if you uncheck this box, this motor will not actually show up in it. There's reasons you'd want to do that, but if you do check this box, you can put in, say, the part number or just a description. So I don't know Baldor part numbers very well, so we'll just say Baldor 10 horsepower part number. And then we're going to say a brief description. You don't actually have to put a lot in here. This is just an example of TFC, 4-pole, 10 horsepower. So, and then we're just going to click next. And so this is what's really important about when we specify our motors. So 10 horsepower, 4-pole, a 480 volt system, has around 12.5 amps. And we're just going to say that it needs 20 amps maximum, so peak. Now, when we set those, the NEMA settings versus the metric settings, it changed these by default to horsepower. If it's not, you can always right-click on this little thing and change it to kilowatts or horsepower. So We're going to say 10 horsepower on each of these. And we're going to click Finish. So now it brings in our 10 horsepower motor. And so that's there. Next thing is going to be select our motor module or our inverter. Another way of saying inverter. We're going to click there, click Dimension Motor Module, and it gives us all of the options for the motor modules that we're going to be using. Since we know ahead of time that we're going to be using 4 motors, we're actually going to select this double motor module here. That way we can kind of save space and save space in our panel. And obviously, this is not all of the options for the drives, but these are the actual selectable components. That just means, hey, because of what we put in on the motor, this drive will actually run it, and it meets all of the kind of restrictions that Siemens puts on it. So if it's on this list, then it'll be able to run that motor the way you've specified it. So we're going to pick double motor module, book size, C-type. Again, if any of these questions, if you have questions about this, drop a comment down in the video comments, and I'll try to answer them, or reach out to your local Siemens distributor, and they'll be able to answer questions like difference between C-type versus D-type, things like that. So we don't have any empty boxes here. So our motor module, we got the check, we're ready to go. So let's move on down to output components. So the first thing is output options. So let's say we're going to put a motor reactor. Say these are pretty long cable runs. Say they're 100 meters long. So we know we're going to need a motor reactor, so we're just going to put that on there. Click OK. Now, next thing is to specify the power cables. There's a lot on this screen, but just know that it goes in, and based on what you have selected in as your motor current, it's going to be able to supply that. Obviously, the motor module can put out 18 amps, but this is based off of the motor itself. The little difference between the Motion Connect 500 and the Motion Connect 800 is just whether or not it's going to be like in a moving cable tray, like on a moving piece of equipment, or versus a fixed mounting, like in just a fixed cable tray or conduit. So we're going to need, we've said that we're going to need 100 meters of this cable. So the reason we were able to do that was because our maximum permissible length down here is 160 meters. If we did not put in that output reactor, this would probably only be 50 meters. So this number is actually based on what is what's actually available with your current configuration. So we have 100 meter long cables going out to these motors. Say OK. A coder evaluation. So if we were to have, say, a pulse encoder, we could say, okay, we want encoder evaluation, and then we could select an SMC30, and that would bring that into our parts list. But we're going to say for this, we're just not going to have encoders. Actually, let's put these on there, because I want to show you how to do that. So we don't have cables. We'll specify cables later, or some other way. So we have this blue section, which is everything to do with the axis itself, which is a motor, motor module, and output components, cables, etc. So we want 4 of those exact same motors. So we can go over here, and we can either say copy, or we can do Control-C. We can click the drive system, paste, or Control-V, and we do that 3 times, and we have 4 motors now. This little drop-down box, we can select if we want to modify one individually. We can do that, but we're just going to move on to the line module itself. So the line module is the rectifier, but in order to specify how it's actually going to be loaded, the first thing we have to do is specify which of these axes is going to be on which double motor module. Since it doesn't really matter on these, we're just going to click Assign Automatically, and it pulls that over there. We're going to click OK. Next thing is dimension how much power is going to be required on the DC link. Now, obviously, we put in 4 10 horsepower motors, and so it's going to say 40 horsepower plus losses. So, plus the switching losses. So again, this is taking into account all the calculations that you don't have to make. Well, this is assuming, under this total power rating, this is assuming that it's going to be using 10 horsepower continuously on all 4 motors, and that's what comes up with that. I'm just going to go ahead and point out this coincidence factor. That modifies that, and I'll explain it to you why you would want to use that here in a second. Because we go, okay, so we have 40 horsepower that's available, and we say, okay, dimension the line module. Well, the smallest size that is available in this line module is 50 horsepower. That might be okay, but what if we were only ever going to actually be using 3 of these motors at any given time? Well, we'd probably only need around 30 horsepower. And if we said, okay, these motors aren't ever actually going to be fully loaded fully, so they're only going to be running at maybe at half their torque. And these are just motors that under normal circumstances will only see peak loads of up to, say, 30 horsepower total. So with that said, we can just take a peek at what else is available by unchecking this box. And we see that there actually is a 26 horsepower line module there that's like, oh, well, maybe we want to actually use that. It won't let us move on because of the red X. So let's cancel out of this and go back to the DC link power section. What we're going to do is we're going to modify this coincidence factor until this gets down to below that 26 horsepower. So that there's 25 horsepower essentially there. And what this represents is if all 4 of these motors are not actually requiring their peak horsepower at the same time. So if you know that because of your process, you're only going to ever use 3 of these motors at any given time, and you're saying, okay, 25 horsepower is enough because of my process, you can modify it this way. What I'm going to do is I'm going to bring this back up to 1, and we're going to go and we're going to select this one. The next thing is going to be braking components. Well, the basic line module doesn't have any regenerative ability, so everything would be, any braking power is going to be going out to heat. So here's where you would select your braking module and some resistors, but I think what we would rather do is go back and say, I want to go back here and change to a smart line module, one with regenerative power. So I'm just going to click on Properties and click here and make my change to Smart Line Module. And then click OK. And you can see it kind of chugging through, and then it goes through and says, oh, hey, everything else is good up to my line module. So I'm going to click on it. Still requires the same amount of horsepower on the DC link, but the line module needs to be reselected. So we go through and select the smallest available. Click OK. Now that we have regen, we don't need a braking resistor, so we're good there. Now, see all the green lights. Next thing, system components. So input options would be like here, like a circuit breaker and a line contactor. Now, the circuit breaker, depending on which region you selected, North American or IEC components, these will be different. So circuit breaker, that selection matters on the circuit breaker. So we say OK. And additional options, just some things there. Now, it looks like your workflow is complete, but if you notice here, it says click here to dimension open closed loop control or open loop control. So let's click there, and you kind of want to come up here, but you actually need to come down here where this checkbox is not checked. So we're going to double click there, and it brings up this new screen. Let's click on the first thing, and we notice we have some red here. First thing we notice is we don't want a Profi bus controller, we want a Profi net, so we can click on it, and then go to Profi net. Now, we're still red, and we see that this processor is being used 140% of its utilization. So what we need to do is go through and lower the performance level of each of these motors. And as you notice, that goes green as we start to do these down. And so now we'll notice that all four of these motors are perfectly fine on one multi-axis control unit, the CU320-2. Well, if we had 10 motors, we would have another control unit, and we would need to add in a new control unit by double-clicking new control unit, selecting it, and then dragging what we need onto the other control unit. We don't need to do that. We can delete this one. So anyway, so we've got green here. We're going to click OK. The installation arrangement is physically how these motor modules and the line modules are installed in the panel. This configuration represents the rectifier in the middle, the line module in the middle, flanked by two double motor modules. And again, this is keeping up with all of the part numbers necessary. And this is also calculating how long your cables need to be. And we'll see that here in a second. Click OK. Because here comes the DriveCliq technology, or DriveCliq. So the first thing I normally do, sometimes you'll come in and this will have a red X here. Maybe you've made a change and it's a red X. You can always click default wiring and then just say yes, create a default wiring. All checks, good to go. Click next. And we're going to look at a couple things here. First thing I normally do is say set all recommended cable lengths. You notice all the green comes into place. And it gives you part numbers, all of that. So you have a couple of things here that are not selected. If you go through and click each one of these, all of the red highlights those actual cables. These, because they don't actually know where you're going to mount these encoder modules, you have to select what type you want. Normally, I use this in fixed lengths, fixed mounting. Click it, and 1.2 meters, 4 feet, that's usually pretty good, because you're normally mounting these directly underneath the drives. If not, then you can always change the size up to, say, 2.8 meters, so 6 feet. So let's do that, and we'll do those for 2.8 meters. We'll go through for each one of these and make sure that all of these are selected appropriately. Oops. That one, then this one. And so that should be everything we need here. Now, come down here. If you're actually done, click Finished. If you click Accept, it'll still close the window, but it won't. You'll have to come right back in. So click Finish. And next thing is the 24-volt supply. I'm going to go ahead and just optimize for the smallest possible 3-phase power supply. It gives us a 10 amp. So we've got that. We're going to say OK. And we're actually done now. So we have all green boxes, good checks, all of that. So if we wanted to, we can go up here and click Display Parts List. And we can click OK and Yes. And we can see all of our parts that are available for the system. It's gone through and specified each individual drive and all the necessary components to put together this system. Problem is, you can't cut and paste this. It just shows it. What you have to do is use a export. So Tools, Export Parts List, and then we're going to click OK, and then click Yes. Click OK. I'm going to replace that demo project, and it'll open up the Excel version of this parts list. So here we can actually cut and paste these part numbers, and it also gives us good descriptions of what everything is. So if you get a parts list from me, this is probably what it's going to look like because I generated the parts list in SIZER. Now, if you're actually ordering this in iMall, a little problem comes up is that there's a lot of duplicate items on here. So like all 4 of these are going to be the same part number, but everything is quantity 1. So it kind of gets a little cumbersome if you're ordering, because you're ordering a bunch of quantity 1s of duplicate part numbers. So there's a solution to this. Close that out. Go to Tools, back in SIZER, and export SAP data. And click OK. Click Save. Yes. 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 And this actually exports just the part numbers and quantities. So this is the power cable, 6FX 5008, and there's 4 power cables. So that's what those are. So when I send over a quote to my inside guys to generate a quote for a customer, this is what they get. They don't get the parts list. So that is actually the basics of SIZER. I know it's a lot, and this tool has a lot more in it that I haven't gone through and shown, but um, this should get you at least in a conversation. And if you have any other questions or like for me to kind of like touch on something else, just drop a comment down below. And as always, if you have anything else that you would want me to discuss and talk about in the next video, please let me know, and I will kind of do that the next. Hopefully next time I'll be able to actually do it live, and I'll be back at my apartment so that I can actually do it live. But until then, just keep keep trying out the new applications, and yeah, have fun.